Okay, Mr. Harden here. We're going to continue doing some more gas law problems here with the combined gas law. And Darian's here to hang out with us too. Okay. Gas expands from a volume of 17.3 centimeters cubed. Volume 1 equals 17.3 centimeters cubed. 2, 24.5 centimeters cubed. Volume 2 is 24.5 centimeters cubed. At the expanded volume, so this is going to be the higher volume. A manometer was used, that's how you measure pressure in the lab, and the pressure was found to be 99.3 kilopascals. So P2 here is 99.3 kilopascals. What was the original pressure of the gas before it expanded in millimeters of mercury? So we're going to look for this pressure in millimeters of mercury here. So we can see here that the units are not the same, and the temperature and the amount are constant. Okay, so we're going to convert 99.3 kilopascals over to millimeters of mercury. Kilopascals on the top, kilopascals on the bottom. What are we going to convert to? Millimeters of mercury. Remember that these numbers are on the formula chart. Swish. 101.33 kilopascals and 760 millimeters of mercury. Okay, and I get 744.77 millimeters of mercury. So now you're going to see me cross out this number and put in 744.77 millimeters of mercury. Then you're going to see me write down the equation. P1 V1 over T1 equals P2 V2 over T2. The temperature is constant, so we're going to cross out the T's. Then we're going to substitute in. So we got P1 equals 17.3 centimeters cubed, which equals 744.77 millimeters of mercury times 24.5 centimeters cubed. So this time, okay, we are going to multiply these two numbers, and then we are going to divide by that number. Okay, so we see that the volume is going up, so the pressure should go down because this is an inverse law. And you remember who has the only inverse law, right? Robert Boyle, the man that has credit for the hyperbola. And we get an answer of P1 is 1050 millimeters of mercury. Now, this is rounded for sig figs. 3 sig figs. So you know. Okay. Okay. Moving on to the next problem here. What would the change in volume be? What would the volume in liters of an 8-point what would the volume in liters? So we're looking for the volume in liters. Let's put that as V2. Of an 8.9 liter sample, so V1 is going to be 8.9 liters. Sample of gas at 100 degrees Celsius. You're right, Darian. We cannot use Celsius. This is going to be 373 Kelvin. Because remember, we have to add 273 to get the Kelvin. And 113 kPa. We know that kPa is a pressure. If the conditions were changed to STP, sneaky, do you remember that STP is 1 atmosphere and 0 degrees C? Yeah, you know me. You do remember that, right? Sneaky! Remember, we can't use 0 degrees Celsius either. We gotta use 273 Kelvin. And we're going to use 1 atmosphere. Problem is that this is kPa and that's atmosphere, so now I have to change the units here. So I'm going to take, the easiest way to do this is take 1 atmosphere, convert this over to kPa. Atmospheres on the top, atmospheres on the bottom. What are we going to convert to? kPa. Sweesh. This is 101.33, and this is 1. So it's actually 101.33. So I cross this out and put 101.33 kPa. Okay. Then we write down our equation. P1V1 over T1 equals P2V2 over T2. I'm going to plug in our numbers. 113 kPa. 8.90 liters. Okay, so it's going to be 113, 8.90 liters over 373 Kelvin equals 101.33 V2 kPa over 273 Kelvin. Now we have to do the algebra here. The variables here. So we are going to circle these 3. We are going to multiply all those 3, because that's going to end up over here when we cross multiply. Which means we are going to divide by 101.33, and we are going to divide by 373. We will get an answer of V2 equals 7.26 liters, and this is the combined gas law. Thanks, Darian. Glad you're here to support me. Okay, you guys are champions. The legend is